Okay, what are polar coordinates based on? Totally different way of plotting points and functions in the plane, right? Totally different way. First variable that we have is, what's the first variable? R or theta? What's the first variable? Theta is first. Theta is like independent, right? So the convention for ordered pairs is to do r comma theta, but that's backwards. Don't know why it ended up that way. Okay, but that's how all textbooks and then the world does it. Is they write r comma theta, but theta is first. Theta is the independent quantity, and so theta is our standard trig angle swept counterclockwise from the positive x-axis, right? And then once for any given theta, so here's theta of 3.6, and what does the 3.6 mean? Why is that the angle 3.6? Should know that before we do anything else with trig or polar coordinates. Why is this the angle 3.6? Could you explain it? Okay, because this angle right here, so this amount of openness cuts off what? That amount of openness. What does it have to do? That amount of openness have to do with 3.6. Right, so this angle, this amount of openness cuts off, what, 3.6 radius lengths of arc length. You need to understand this. So if I pick a radius of 2 here, pick a circle radius 2, this one right here, then this amount of openness, right, this angle theta, means that this arc length is 3.6 radius lengths, where this is the radius, right? So we picked a radius of, I picked that radius right there. So it takes 3.6 of those around the arc to achieve this amount of openness, that angle measure. So that what I drew in blue there is 3.6 radius lengths, and that's where we get radians from. That's what it means that this angle is 3.6. So all those pi over 2, 3 pi over 4, 5 pi over 6, those are numbers. Those aren't labels for places. Those are numbers, right? If you put in that, you get put in 5 pi over 6. You get a decimal approximation. You get a number. And that number is how many radius lengths it takes for the amount of openness. So that number of radius lengths determines an amount of openness of the angle, right? So 5 pi over 6. Where's that? Right about, that's the closest I can, right about there. That's the closest I can get. Nope, that's it. Right there. This gray line right here is 5 pi over 6. That one right there. So what does it mean? It means whatever the 5 pi over 6 is about 2.6 radius lengths. So it takes 2.6 radius lengths of arc length around any circle. We'll get that amount of openness of the angle. Okay, so then what comes next? We have theta, and then for a given theta, we pick some value of r, right? And r then is how far you go from the pole. The pole now is our new name for the origin. The pole, how far you go from the pole in the direction of the terminal side of your angle theta, right? In the direction. And so the negative angles are in the exact opposite direction from whatever positive theta is. Sorry, negative values of r. Negative values of r. Okay, so that's review. So let's think about taking the old rectangular coordinates that we're used to and polar coordinates, and let's lay the planes on top of each other. We're going to talk about transitioning back and forth between the two, right? So given a point, in the plane, so what is this? This is like 0.69 radians and something like 3.5. But just imagine it as any point, right? Imagine it as any point, any theta, and any value of r. And the question is, what is the corresponding xy coordinates of that point? All right, so I've got, this is just an arbitrary point. It could be any for any theta and any r distance from the pole. It's not on your smartphone. And so we want to know what's the value of x and y for that point. So it goes back to, what is the meaning of the x coordinate in rectangular coordinates? So if we missed it on the quiz last time, do we know it now? What is the meaning of the x coordinate in rectangular coordinates? Horizontal distance, right? It's a horizontal position or horizontal distance, distance from the y-axis. Okay, so can you really see is the line on a line right there? Is that line the same one? Yeah, it looks pretty good. So this is what we mean by the x coordinate, that distance from the origin to. So I could have put that up here, right? Same thing, x going across here. And the y coordinate is vertical distance from the x-axis. Or vertical position, right? Our y coordinate's vertical position. So now we've got, and what's r? R is our distance out here to the pole. And this is theta. So what is x? What is x? We want to find x in terms of theta and r, right? We want to know what x is in terms of our polar coordinates, theta and r. So you should be thinking trig right now. You should be thinking trig. We've got a right triangle, right? The x and y coordinates make a right triangle. And so we have our trig relationships, right? X is, or cosine theta is, what's cosine theta? It's going to be x over r, or, and so x is r cosine theta from our trig relationships, right? And y is? So this would be if you had your polar coordinates and you wanted to convert to rectangular coordinates. X is going to be r cosine theta, and y is going to be r sine theta. Okay? What's another relationship that we have? So suppose we have x and y and we want to get r and theta. What relationship could we get r from x and y? That one's easy, right? What is it? X squared plus y squared equals r squared. So r squared equals x squared plus y squared. And how can we get theta from x and y? So what relationship brings together theta, x, and y? Tangent, right? Tangent of theta equals y over x, therefore theta is inverse tangent, right, of y over x. Now, we know inverse tangent has a restricted, right, or it has a restricted range, right? The range of arctangent. This will always give you a number between negative pi over 2 and pi over 2. So if your theta is in the second or third or fourth quadrant for a positive angle, you're going to have to make an adjustment. Okay, so that you should have learned that in pre-calc. All about arctangent and how you'll only get, from arctangent, you only get an angle measure between negative pi over 2 and pi over 2. And then there's adjustments that have to be made if your angle is outside of that range, right? If your angle stays in the second quadrant or the third quadrant, you need to use arctangent and adjust it to get the angle that you want. So I don't have time to go through that. Yeah.
Is it between, or is it between, like, less than or equal to pi over 2?
Yeah, so it's between, because otherwise you would have it would be undefined, right? It would be undefined if it's vertical. Okay, so this then is our relationships for if you have x and y and you want r and theta. Any questions on that? Okay, so last time we were working on, we were doing the function, we were using polar coordinates to graph r equals 2 sine theta. So let's go back to that one. And you remember what we did. So just as a quick recap, we graphed it in rectangular coordinates, putting theta on the horizontal axis and r on the vertical axis. And we came up with this graph of 2r equals 2 sine theta, like this. 2, 0, negative 2, pi over 2, pi, 2 pi. And we said, as theta changes from 0 to pi over 2, what does r do? We use this graph to answer that question. As theta goes from 0 to pi over 2, what does r do? Goes from 0 to 2. So here it is, watch. So it's going to go from 0. So that point, see that point? It's going to go from 0 to 2. And so if we trace those points out, we got this curve, right, like this. So that's what? That's as theta increases from 0 to pi over 2 through the first quadrant, the r is slowly increasing, right? So it's increasing. So small r, but a little bit bigger r for each angle theta. R is increasing until when we get to pi over 2, it's 2. And then it undoes what it did from pi over 2 to pi. It goes back down from 2 to 0. And so we ended by asking the question. Oh, no, let's just keep going here. So what about from pi to 3 pi over 2? So what about from pi to 3 pi over 2? What does the r value do? 0 to negative 2, which would graph where? So if you imagine in our angles in the third quadrant coming down here, where are the negative values of r as we sweep through the third quadrant here? First quadrant. So here would be at 0, and then we would decrease to negative 2. So what are we going to get? So as theta changes from pi to 3 pi over 2, what's r going to do? R is going to increase negatively to 2. So do you see that we're just going to get the same thing again right on top of it? It's going to plot all those same exact points, but this time as angles in the third quadrant and negative values of r. So watch it. It's just, you're not going to see anything happen because it's just replotting the same points right on top. So look at the negative, the red axis, and imagine r. Yes, you can see the point. See the point? It's just recreating it, but now r is negative. So there, and then finally, as theta goes from 3 pi over 2 up to 2 pi, it goes from negative 2 to 0. Watch the point. Watch the point. Ready? So it's just traced along those same set of points. So here, the period of the sine function is 2 pi. But this same function, r equals 2 sine theta, what's its period as a polar graph? How long did it take before it repeated? How long was one cycle? Pi, right? So all those points got repeated, and all it took was pi. So notice the period doesn't match up, right? So the period of 2 sine theta as a rectangular in rectangular coordinates is not the same as the period in the polar plane, right? The period was pi. It only took a change that's from 0 to pi to get all the points on the plane. Okay, and then we ask the question, it kind of looks like a circle. Is it a circle? Circle or not? Now we're going to answer that question. And we can answer that question by taking this equation and converting it into x and y. All right, so we're going to use our relationships that we just found by putting the polar plane on top of the rectangular plane on top of each other. And so we don't know what sine theta equals, but what do we know? What do we know in those relationships? Okay, so what did we say? X equals? Okay, off your cell phones. Heads up, here we go. X equals r cosine theta. Y equals? All right, so we don't know what sine theta, but we know what equals. So sine theta is almost what? Y. But what is y? R sine theta. So what if we multiplied this by r? Then we would have basically y on the right-hand side. You see? But you can't just multiply one side of an equation by r. You lose the equation, right? So r squared. And that's convenient too, because we know exactly what r squared is. What's r squared? X squared plus y squared. And 2r sine theta is? 2y. So I just change this into rectangular coordinates. And so we say, is this a circle? It sure looks like it. And let's figure out what circle it is. So we do x squared plus y squared minus 2y equals 0. And if you remember the equation of a circle, it's x minus a quantity squared plus y minus b quantity squared equals the radius squared. So in order to get y minus b quantity squared, we have to do what's called completing the square. You should have seen this in your past, right? Completing the square. How do you complete the square? You take half of the linear coefficient and square it. So we take half of negative 2, which is negative 1, and we square it. Positive 1. So if we had positive 1, we just completed the square, and now we have a perfect square there. So half of the linear coefficient squared. But if we add 1 on the left, then we have to add 1 on the right. Got to maintain equality, right? So we get x squared plus. If we completed the square correctly, that means we have a perfect square. What perfect square is it? Y minus 1 equals, we can think of this as 1 squared if we want. So this is indeed a circle. Center is 0, 1, right? X minus a squared, y minus b squared. The center is ab, right? So it's 0, 1. Radius is 1. So look, center we said 0, 1. There's the center. 0, 1 in rectangular coordinates. The point 0, 1. Radius 1, right? It reaches out distance of 1 in all directions. So it is by doing the math here, by converting our polar coordinates into rectangular coordinates, we indeed get the equation of a circle. A circle whose center is 0, 1 in rectangular coordinates and whose radius is 1 from that point. Okay, so polar coordinates, because it's based on r, which is a radius, right? R is a distance, is very conducive for circles. So what would be the equation, say, of the circle whose center is 0 and radius 3 in polar coordinates? So I want the equation center is 0, center is the pole, and whose radius is 3. What would be the equation in polar coordinates? So we know in rectangular coordinates that'd be x squared plus y squared equals 9. But what's true about every point on the circle with radius 3? What's true about r? R equals 3 for every angle. So that's it. So that circle that I described is just r equals 3. No matter what the angle is, you want to go 3 away from the pole. And so you get this circle. So again, notice that polar coordinates is very conducive to circles. You get nice, clean equations in polar coordinates for circles. R equals 3, r equals 2 sine theta, right? What about lines? Are lines conducive to polar coordinates or rectangular coordinates? So let's do y equals negative 3x plus 2. So that's nice and clean and tidy in rectangular coordinates. What would it be in polar coordinates? Y equals r sine theta. X equals r cosine theta. And in polar coordinates, we write, so r is dependent on theta. So we want to write r as a function of theta. So what do we do to do that? We're going to have to bring this over. So we'd have r sine theta plus 3 r cosine theta equals 2. Factor out r and divide. Can I do this 2 steps at once? Can I factor out r and then divide by the rest in one step? R equals 2 divided by what? Sine theta plus
3 cosine theta.
How's that? Nice convenient equation there? Is that right? 2 divided by sine theta plus 3 cosine theta. This is it's nothing like y equals minus 3x plus 2, right? So r equals 2 over sine theta plus 3 cosine theta is, it's kind of a complicated, non-conventional equation. And that's underscoring the point that lines, polar coordinates isn't made for lines. Okay? Polar coordinates isn't made for lines. Now, I could put it in and it'll work, right? So I'll put in, instead of 2 sine theta, I'll put this in. 2 divided by sine theta plus 3 cosine theta. And we'll see what we get. So it works. We got it. We get that line that we were more familiar with as negative 3x plus 2, right? Negative 3x plus 2. But polar coordinates isn't really suited well for lines, and so you get a weird equation when you do a line in polar coordinates. Okay, any questions on that? Okay, so we need to get lots of practice sketching these polar graphs. Okay, sketching these polar graphs. So next one we want to do is we're going to work on 3 cosine theta plus 1. 3 cosine theta plus 1. So what are you going to do? You're going to, I have more, if you don't have your paper from Monday, I have more paper. Thank you. Let me pass these out. So what I gave you Monday was double-sided, so you have 12 different polar coordinates, but if you need more, you can have more. So I want to see how far you can get by yourself while I take some attendance. But you're going to first sketch 3 cosine theta plus 1 this way, with theta on the horizontal axis and r on the vertical axis. So that's on in your own notes. Get 3 cosine theta plus 1. Make sure you get that right. Make sure you get that right. And then you're going to use that graph to start sketching the polar graph of 3 cosine theta plus 1. Okay, no calculators, no technology, okay? This is all by hand. And remember how we do that. So you think about theta varying, say, from 0 to pi over 2, and you ask, what does r do? As theta varies from 0 to pi over 2. And then you imagine theta sweeping through the first quadrant, and r changing with theta according to the graph that you drew. My experience is this is difficult for a lot of students, so we got to practice. Okay, so do your best to get started, and I'll take some attendance, and then we can regroup in a couple minutes. But again, the key is as theta goes from 0 to pi over 2, r does what? As theta goes from pi over 2 to pi, r does what? Again, so this is the covariation again, right? Two variables varying together. Whatever it takes. Whatever it takes to get the whole period of the polar graph. The whole polar graph, right? So the whole polar graph. Whatever it takes in the rectangular coordinates to get the whole polar graph. Okay, so tell me about 3 cosine theta plus 1. Let's see. Jillian, can you tell me about 3 cosine theta plus 1? Did you graph that? At 3? What about the plus 1? So yeah, 3 cosine theta would go from 3 to negative 3, but then it's all plus 1, right? Shifted which way? No, because this is going to take all the y values and add 1 to the y values, right? Vertically. So it's going to start at, so what's the midline of this? 1, right? So it's going to have a midline of 1. And then it's going to have a max of 4 because of that plus 1. And a min of negative 2. All right, so this thing is going to be centered on 1 and have a max of 4 and a min of negative 2. Okay, and cosine starts where? Max, midline, or min? The max, and it goes down to the midline to what angle? Pi over 2, right? So it's gonna hit the midline or 1, r equals 1, when we're at pi over 2. And then it's going to go from the midline to the min when we hit the angle what? Pi. So down here, angle pi. And then from the min back to the midline at what angle? 3 pi over 2. And then back up to the max at 2 pi. So we've got to have that graph right. So we're not going to be able to get the polar graph right if we don't have this graph right. So make sure we know how to do those. Any questions on that so far? So then what do we say? Theta. So theta goes from 0 to pi over 2. R does what? R goes from 4 to 1. So at 0 we're at 4. And then at pi over 2 we're at 1. Now here's a really big mistake the students make. They kind of draw just almost like a line from there to there. Okay? But you got to imagine this gradually decreasing from 4 to 1 as the angle turns. So let's see what that looks like. So we can kind of do it ourselves. So you think about r decreasing just little by little, right? R is decreasing little by little. So that say when say you're about here, are you going to be greater or less? Is r greater or less than 1? Greater, right? Because you haven't gotten down to 1 yet. So you're going to have points up here. So that's why kind of drawing a straight line doesn't work, because when you get close to 1, you're going to have values greater than 1. And then, so does that make sense? So let's look at it. So now I'm just going to illuminate the point. So here's, nope, wrong one. This one. So there it is, 4, right? There's 4 when theta equals 0. Now watch what happens when theta increases. So see how, look how high up that is still. It's because by here it's gone down to 3. So now do you see that R is 3 here where it was 4 to start. But look how way up above higher than 1 it is, because why? Because it's greater than 1. So don't draw a straight line from here to here. Watch it again. Watch how R decreases. R is decreasing here as theta increases, and then it reaches 1 at pi over 2. So let's see what that arc looks like. So here's the arc being drawn. Ready? So that's R decreasing from 4 to 1 as theta increases from 0 to pi over 2. Okay, so now it gets trickier. Why? Because we're going to have some negative angles in here. Or sorry, negative R values. So as theta goes from pi over 2 to pi, what happens? R does what? R goes from? But in between, it's going to hit what?
0.
It's going to hit 0, right? So it's going to go from 1 first to 0 and then to negative 2. And is it going to hit 0 closer to pi over 2 or closer to pi? Do you see that it hits 0 pretty quickly, right? So for just a little more sweep of an angle, we hit 0. And then for the rest of that quadrant to pi, we're in negative territory, going down to negative 2. So what does that look like? What does that look like? So we let theta increase a little bit here from pi over 2, and do you see that the radius shoots down to 0? And then, as we continue in that quadrant, do you see the point? Going from 0 to negative 2. And we just reached pi. Okay, watch the point again. So going from positive 1 to 0, and then from 0 to negative 2 as the angle sweeps from pi over 2 down to pi. So what does that look like? Let's turn it on. Here's what we've done so far. So from 1, so as the angle increases from pi over 2 to pi, we go from 1 to 0, and then from 0 to negative 2. So before I started graphing this, how many people got something like that? Anybody? So this is hard. We're going to need lots of practice, okay? Need lots of practice with this. Okay, then what happens next? From pi to 3 pi over 2. What happens to R? As pi goes from pi to 3 pi over 2, R does what? R goes from? Negative 2 to 0, close to 3 pi over 2, and then 1 at 3 pi over 2. So it's going to go, so imagine the angle, we're sweeping this way, right? We're sweeping this way, and R is going to go from negative 2 back to 0. Watch the point, right? Watch the point. So there it goes from negative 2 back to 0. As the angle sweeps to about there, and then the rest of the way to 3 pi over 2, we get back out to positive 1. Watch it one more time. So as we go from pi to 3 pi over 2, the value of R goes from negative 2 to 0 in most of that quadrant. There's going to negative 2 to 0, and then to positive 1. And so let's watch that get traced out. So from negative 2 back to 0, And then finishing off that quadrant to getting to 3 pi over 2, the radius gets to 1. And then the last quadrant compared to that is easy, right? Because we go from what to what? 1 to 4, right? So now in this last quadrant, as we sweep from 3 pi over 2 to 2 pi, that radius is going to increase from 1 to 4. Okay. Questions? Anyone? Did anyone get something like that before I started? You did. Congrats, but this is going to take lots of practice. So we're going to have written homework for Friday. We're going to be practicing these, and you want to practice without a calculator. So you got to practice. Know how to sketch this graph. Use this graph to sketch this graph. So let's try 5 sine 2 theta. See if we can finish that. 5 sine 2, r equals 5 sine 2 theta. Unless there's a question about this one. Yes, please.
So it's like we cannot convert between a polar graph and a Cartesian graph for every function. Like previously you showed us how to get the same line with polar coordinates for...
Exactly. So we would not expect a nice, easy equation of x and y for this thing, right? Yeah. This would be in rectangular coordinates would be very weird, very out of place. Likewise, if you tried to change that 3 cosine theta plus 1r into x and y, it would be a mess. It would be awful. And that's because it's not suited for x and y coordinates. Great question. Yeah, great question. So 5 sine 2 theta. 5 sine 2 theta. Make sure you have that first graph right. Okay, the first thing you should notice about this, you get a full period now every pi, right? Because when theta hits pi, sine will do 2 pi. So it only takes pi now to get a full period. So then I drew out 2 cycles to 2 pi. So here we go. When theta goes from 0 to pi over 2, what does r do? R goes from 0 to 5 and back to 0. So really we want to maybe break this up into pi over 4s when we talk about the ranges of theta. So as we go from 0 to pi over 4, r does what? It's going to go from 0 out to 5. Can you imagine what that will be like? And then from pi over 4 to pi over 2, r goes from back to 0. So it's going to go 0 out to 5 here, and then back to 0. Can you imagine that? What that will be? Let me show the points. I'll show just the point, right? It's the wrong one. So 0 out to 5 at pi over 4, and then back to 0. So this is kind of like loops out there, right? It loops out to 5 at pi over 4, and then back to 0 at pi over 2. Looks like this, ready? Out to 5 at pi over 4, back to 0 at pi over 2. Okay? From pi over 2 to pi, that's in this second quadrant, but all the r values are negative. From 0 to negative 5 back to 0. So what quadrant will that graph in? It'll graph in the fourth. Watch. As we go from pi over 2 to 3 pi over 4, r goes from 0 to negative 5. And then from 3 pi over 4 to pi, negative 5 back to 0. That was this part of the graph right here. Now we're back in positive territory in the third quadrant, from pi to 3 pi over 2, up to 5, positive 5 here, back to 0, and then negative territory, 0 to negative 5 to 0.